Welcome back to Algorithm Visualized. This is Golden Thumb. So in this video, let's play with some basic recursion in Java. Okay, let's get started. So recursion is something, if you know it, it's easy. If you don't, it's pretty hard. So we need to do a lot of practice and try to get comfortable with that. Okay, so let's create our, like, the first one, the typical classic factorial. Okay, so let's do factorial.java. Okay, so let's create a class factorial app, and of course we need static void the main method string args, and yeah, we can put a space here. Or now this is the entry point. So let's create a function, static function like factorial. Okay, let's calculate n factorial, so it returns an int, right? Factorial. Let's create a normal one, iterative. Yeah, so we input, this is the input. So using a for loop, everyone knows that it's easy, so we use for like int I equals 0, I less than n. Oh, actually we need the product, right? So int product equals 1. Then here I start from 1 and I is smaller than or equal to n I plus plus. So we can do product times equal I and return product. That should work. So let's test it. Sorry, system.out.print line. Let's calculate the factorial of like 5, because I know the answer is 120. Okay, so let's compile it. Java C factorial.java and Java factorial app. 120, great. Okay, now let's create another recursive version of that. Here, static recursive factorial. Okay, and tn. How do we do that? Base case goes first, right? We can use 1 as base case or 0. Yeah, I like 0 because it's more pure. So if n is 0, we just return 1, right? We know 0 factorial 0, right? Mathematically it's defined, yeah, it's 1. Okay, so otherwise we need, right, to get the result of the sub problem, right? The same problem like n minus 1 factorial. So we understand n factorial is n times n minus 1 times n minus 2, right? And dot dot dot. But so this part can be solved by the recursive call of the same function, right? Recursive fac. Okay, so now we can do int rest the rest of the job is handed to recursive call of n-1, right? Like that. Then what we need to do our small step to figure out the final answer, right? Return rest, right? N times rest. That's it. So let's try to, okay. Let's print out both of them, rec and the fac, like that. Oh, I missed the return type. $120. Okay, so if this the first time, right, you play with recursion, we need to yeah, we can play go deeper. So let's remove those things. 6dd, delete that, and delete that. So let's put a print here to see, right? The n equals n, like that. And we can also print out. Okay, let's try this first. So the first passed in parameter n is 5. The second one is 4, right? It makes sense. When we calculate the 5 factorial, we call the function. Yeah, here is the code. Factorial. Yeah, here's the code. The first time when we call, right, recursive fac, right, 5, then n is not 0, so we enter the recursive call for n-1, which is 4. And next, right, when we calculate the 4 factorial, we need to call the same function with parameter or argument 3. Okay, if we print out the rest, is more interesting here. Rest equals rest. Okay, now what happens here? You see, oh yeah, we can see something here, right? Rest, when we try to get the factorial of 0, the rest is 1, right? And when n is 1, the rest is 1. Okay, I think we can print the product here instead. Let's do this. Answer equals n times rest. So we can return answer here, and we can show the answer. Like that. So this is the answer returned every time by the recursive function call. Let's see. Yeah, this is I think this is more interesting than that one. Yeah. So to calculate 0 factorial, 1 is returned first. And then the 2 factorial, right? Which the answer is 2, is returned before we can calculate 3 factorial. Then this is 3 factorial. It returns. So try to understand, right, why this happens. Yeah, it helps understand the recursive thing. Okay, I think we can stop here, and we'll have other similar recursive practice in the next video. Thank you for watching. See you next time.